What's that?
And thanks so much for coming, and hello to all of you. Who's here from? Who's a work grad student? Raise your hand. Who's a med student? Raise your hand. Who's an engineering student? Raise your hand. Any other schools that I missed? Shout it out. Sweet. Awesome. Anyone not in school? Raise your hand. Okay, awesome. Thank you so much for coming and taking time out of your day. We know you're super busy. And hello to our friends in our live stream too. Health AI has a bunch of partners, including Wharton, Penn Medicine, as well as our partnership with Stanford. So thanks for those that are maybe just waking up and tuning in. Again, since this is live streamed, please, if you have to leave, do so as quietly as you can, and we would really appreciate that. So we're a young and growing organization. I'm going to let my co-founder, Christy, take it away and tell you a little bit about our org.
Hi, everyone. It's really gratifying how many of us showed up from various communities. So if we can go to the next slide. Okay. Some of us may have seen this quote. I, not too long ago, read this quote. I'm no engineer, but it kind of sounded important. So, especially, I've heard a lot that AI might impact healthcare. And as somebody who has some frustrations about our healthcare system, as a medical student and now also a business school student, I wanted to learn more. And last year, when I tried to find more resources to learn more about AI and possibly how I could use it to maybe improve access issues in healthcare or efficiency issues, I didn't really want to learn coding, but there really wasn't sufficient resources for me to learn more about it. So we can flip to the next page. When I dug in a little more, also having been involved in growing a machine learning top-up startup that addresses the issue of access to proper healthcare resources, I really noticed that there's a gap. There are a lot of well-intentioned, hardworking people working in various communities that impact healthcare, however, very much so in silos. So, as a student who is eager to learn more and also maybe in some ways change the world, we created this Health AI Network. So basically, it's a community, it's a network of people like us who are interested in AI and healthcare and really just want to make the healthcare system fit better in serving human beings that we care about. So our first goal that we're starting today is really creating an educational platform to get everybody in the healthcare ecosystem on the same page about what AI is and their applications and issues relevant to healthcare. So without further ado, I'm going to pass it on to Lucy to lead us in the panel and also share us about a primer that we're about to launch.
Yeah, exactly. So our focus for the fall semester, and I'll keep this quick, is again on educating and giving everyone a little bit of a foundation of knowledge on Health AI. That's starting with my speaker series kicking off today with this wonderful panel. We have a lot of great speakers lined up this fall, including Don Rumper, who is leading our nation's healthcare IT strategy, Dr. Bill Hansen, who's our Chief Medical Information Officer at Penn, and several more cool startups and VC investors and our Health AI Startup and VC panel. So in tandem, in parallel with these speakers, we're also creating the Health AI Primer, and it's sort of the text and the content that goes along with these speaker series. It's for anyone and all who are interested in like taking that first step in Health AI, gaining that knowledge that you can start having these conversations, knowing what you don't know so that you can start thinking. And here's hot off the press some of our diagrams. We started off by talking about what is actually AI, what is the definition of it, how do you differentiate machine learning from AI, deep learning from machine learning, et cetera. And we walk you through the patient life cycle and how different parts of the care journey might touch health AI. So please subscribe to our newsletter and our listserv if you'd like to receive notifications. Okay, so with that, I'll go ahead and introduce our panel. We have Professor Eaton here, who's the Department of Computer Information Sciences at the Engineering School here at Penn. We have Dr. Hani Salib, who's a Director of Partnerships and Solutions at IBM Watson Health, which is their healthcare division. And then we have Dr. Charles Khan here, who's Professor and Vice Chairman of Penn Medicine's Radiology Department. Great.
Sure, hello. Very happy to be here. My focus is primarily on machine learning and interactive AI. So I work specifically on a project called Lifelong Machine Learning. It's all about how do you build over an extensive lifetime of experience on one or more related projects. So most machine learning is very similar, think back to middle school, I guess, where you get a bunch of data, you fit a model, and then remind us, fix that model and you apply that model. And that's how most machine learning is. Get a bunch of data, learn a model, apply that model, and then throw that model away. I think that's ridiculous. I think instead what should happen is the system should build upon its previous experience. So not only transferring knowledge from other related problems, but also accelerating learning on new tasks, meaning needing less data samples and less experience in an environment to learn sufficiently. So my work primarily applies this to applications in robotics as well as medicine, looking at problems like interpretable AI models, or how you can take and generate models that will provide the ability for a clinician to go into them and really understand why they made the decision. We're also looking to other types of applications of, say, computer vision and machine learning to automated diagnoses in some cases, where what you're trying to do is allow a clinician to look at more cases within a fixed amount of time. Or you could also look at particular applications where you're trying to prevent medical errors from occurring. So, for example, in endoscopy, if, for example, a particular portion of whatever you're visualizing is missed by the endoscope. And so what you can do is you can detect that you missed that particular region and go back and warn the clinician that they should go back and examine a particular aspect of the surface that they might have missed.
Hi, everybody. This is Hani Salib from IBM. AI and machine learning in IBM is a whole business unit to itself. Kind of give you a big picture. Our business is kind of separated a lot of segments, spanning life sciences, med device companies, providers, payers, government, and colleges. Those are kind of the five major areas. In each of those businesses, we focus on both organic and inorganic opportunities to create solutions and products that leverage AI, or IBM, what IBM calls positive technologies. Some of these technologies are from IBM research, some of them are acquisitions, some of them are organic. A lot of these products, and we'll talk about it over the next hour or so, are leveraging what's called NLP, natural language processing, right? Or text mining. Right? So I, from a background perspective, I'm an engineer in computer science, undergraduate, but I hold kind of more of a business development, product management role at IBM now. But the focus really is how do we leverage natural language text mining of our products, right? How do we leverage unstructured data? Most people think of unstructured data as text. Unstructured data is also images. Unstructured data is also videos. It's also music, whatever you want. So how do you leverage and consolidate all these products, capabilities, solutions that are needed to do a couple of different things? One is to help accelerate point of care solutions for patients, right? To accelerate or reduce costs from a financial perspective, health systems, insurance companies, right? Or to improve processing of maybe of tasks that are relatively mundane or time consuming. So in all these things, we actually look at opportunities from a market perspective, from a development perspective, but also what can we actually frankly deliver to clients and hospitals and patients, right? So from a business perspective, or the only person from a for-profit perspective here, won't take it against us. But from a for-profit perspective, we can't be everything to everybody. We have to evaluate that. Where can we be? Where do we want to be? From an IBM perspective, we focus across all the segments I mentioned. We have really specific niches in imaging, very specific expertise in oncology, diabetes. Those are kind of our four major areas. But in general, we try to build capabilities and solutions platform. These are examples of use cases and applications that leverage AI, machine learning, natural language processing, image technology, as examples of what patients, clients, partners would deliver on their own or in partnership with us. I hope that gives you some perspective.
Hi, good afternoon, everybody. My name is Chuck Kahn. Here I'm faculty in the medical school, and I'm a professor and vice chair in the radiology department. Part of my responsibilities there are to oversee informatics and all the information systems for the radiology department and for connected also to medical imaging for the health department. I want to extend my thanks to the organizers for inviting me. This is really a great forum. My background before going into medicine actually was mathematics. Then I decided I needed to do something like a job. This is in the days before, Wall Street had lots of opportunities for people with a math background. But I love what I do in medicine. My interests actually in math were more theoretical, but since I've been in healthcare, my goal has been to apply a lot of this as practically as possible. As it turned out, where I did my residency training in radiology was one of the centers that was doing a lot of work in AI. It wasn't really called AI necessarily. It was some of the early work in artificial neural networks. A lot of it evolved into systems that are actually in clinical use today that do what's called CAD, computer-aided diagnosis or computer-aided detection in mammography, which has had kind of a mixed history actually in terms of success, even though it's been around for about 25 years now. There's a lot of excitement, obviously, and I'm just curious, how many people believe that AI is something that's happened in the last 5 years? Okay. As many of you know, I mean, even the term has been around since 1956. It's really AI very broadly is trying to get machines to do things that emulate or capture or replicate behaviors that we think of as intelligent behavior, which is a little bit self-serving if we think that a lot of the things that we do are intelligent. But there's tremendous opportunity, and it spans the range from detecting findings in medical images, making medical decisions, directing robotic devices, and there are tremendous opportunities in the field, as many of you have gathered. So it's really an exciting area to work in.
That's actually a good transition, because maybe some people do think, we have been hearing that in the past 5 years, increased buzz around AI. What's been going on from a clinical, business, and academic standpoint that is causing this increase?
Well, I guess the analogy that I make, for those of you who are familiar with radiology, we have something called PACS, Picture Archiving and Communications. The idea that instead of looking at pieces of film, we moved into the digital world. We knew it was coming, but the thing that made the difference, the thing that made it financially and operationally feasible was commercial off-the-shelf technology. The fact that computer monitors that were, let's say, 14 by 17 inches, the size of a sheet of film in those days, went from being $100,000 to a couple $100. And the large part of it that's been driving a lot of the excitement right now with AI has been the move to GPUs, graphical processing units, and that's been driven by computer gaming. It hasn't been driven primarily by sort of the AI community or other things, but a lot of it has come from other pressures, and that's what's enabled it technologically and reinvigorate the whole.
Yeah, just to add on, so one of the things to think about also from a different perspective is there's a couple different market trends in this, right? So when I did my doctorate, it used to be called data mining. Data mining 20 years ago, essentially data mining. There's AI, which is cognitive, all very similar but different. But the thought process in the last, I say 10, 15 years is that you have a sheer explosion of data. You have a cost of software and hardware that's diminishing exponentially. And you have software tools that makes it easier for average people to use. Right? So it used to be in my days, right? We needed a PhD in computer science to do anything data. Right? You have to write your models, you have to go from scratch. Nowadays, there's a lot of off-the-shelf products that you can leverage and enable a model. Right now, I'm not saying these are sophisticated models, but you can actually use off-the-shelf. So we have folks who are in marketing, business, and sales doing lightweight machine learning and AI types of solutions. Right? So a lot of ways that buzz is getting right. And usually, you know, if you follow Wall Street, you know, and you're an investor, there's always every 5 years there used to be a big buzz about where's the money at. All that, you know, overhype or not, invested in Wall Street, some their money for somewhere else. So one thing I want to caution against is the term AI as you get from the popular literature versus the way most scientists think about it. So AI to me is really the umbrella field that, as you said, encompasses things that we think require human intelligence. And so this includes not only aspects of things like machine learning, which is people oftentimes conflate with AI. So machine learning is all about, given a bunch of data, how do you go from that into a model to try to either make predictions or understand what is going on in data, which links into data mining. But there's also a bunch of other aspects of AI which are oftentimes conflated with that now. So these include things like the algorithms that Google Maps uses to make you give you the route from one location to another. Logical reasoning methods, think of which could solve problems that you might usually see on things like the SAT. There's also other things on planning which allow logistical companies use to sequence a bunch of operations to get goods from one location to another, or NASA uses to help the Mars rover plan out the sequence of actions that that's going to take to achieve a particular goal. So all of these are AI. Machine learning happens to be one part of AI, which is getting a lot of attention right now, mostly due to the applications that people have been able to enable that weren't possible before. From, as you said, the availability of hardware, software that makes it easy for people to use, as well as abundant data. There are still, though, a lot of fundamental issues with machine learning which can complicate things. So one example is if you have a very small amount of data and you try to learn a model for it, there's often a tendency for the model to overgeneralize. And so you start making poor predictions. So things like overfitting the data, having sufficient training samples to justify a prediction. All of these are still very, very relevant. And I've seen articles which are starting to come out of taking AI and machine learning and applying it to other fields where some of these issues are swept aside. So they might have a very small training set that's the data that you use to build up a model. And from that, they come to their model and start applying immediately, even though that model might have dramatically overfit the training data. And so consequently, it doesn't generalize well to new cases. So these issues are still there, and it's important if you're interested in getting into AI and machine learning to try to understand where the pitfalls are of making these applications, where things can really go wrong. In some cases, and you're doing some kind of toy app, the stakes might be quite low, but in healthcare, the stakes are much more dramatic in many cases. Patients' lives are at risk, medical decisions are being based on it. So there's some other complications, which are the training data itself. Oftentimes, this data, depending on how it's gathered, can have inherent biases. And so if you're training a model to get, say, one particular sociodemographic portion or one particular
set of genetic predispositions to a disease, and then you take and apply that model to some other population that doesn't fit the distribution, now all of a sudden you could be making predictions which are radically wrong. One example of this comes from law, where during sentencing, judges would use prediction models to predict recidivism rates for felons to see whether they're likely to recommit a crime. Those data that was used had inherent biases that was causing the model to predict certain demographics to likely commit crimes in the future. And so consequently, those particular populations receive harsher sentences than other populations. Obviously, this is very, very bad. We want to avoid this in many cases. Medicine has a lot of these types of scenarios, in this case, due to limited data sets, due to siloed data sets that you may not be, they're not publicly available, right? Due to regulations and so forth. All of these are issues that we have to contend with when we're taking and applying machine learning or AI techniques into medical applications.
That's a fantastic point. Piggybacking off of these challenges, can we talk a little bit about adoption and commercialization of some of these technologies, or adoption time? What are some of the reactions that you're seeing in the market?
Sure. So commercialization actually is a big lot of these technologies that are, some are maybe more mature than others, but I would say probably the earlier cycle of maturity. One of the things to think about is, especially as new technologies start emerging, is identifying a couple of different things. One is, there's a lot of hype about let's use AI for whatever it is. Okay? The question becomes is AI the right tool or capability for that problem? Two, what's more important is what problem are you solving? Right? Using AI just for the sake of using AI doesn't get you anything. Right? But the thing is AI the right tool or machine learning or data mining, whatever your term that you like is, what problem are you trying to solve? Right? So let's talk about the concrete field. Let's say, I will appreciate this, physician fatigue. Right? Physicians are overwhelmed now, much more than they were 5 years ago, much more than 20 years ago. Right? The number of physicians that I know who are deciding to leave medicine is overwhelmed. Why? Because they're overwhelmed with work and sometimes support that. Right? And so the idea here is how do we help physicians do their job faster, better, with less effort from a technology perspective? How can we accelerate that process? Right? So it's kind of problem one. That's kind of the general problem. Problem next step really is figure out which area you want to focus on. Right? So let's take an example again in the area of primary care or in radiology. You look at a physician that spends 15, 20 minutes with a doctor, they only have the doctor 15, 20 minutes to figure out the EMR, figure out what happens in the last visit, what the lab results look like, what kind of history they have, what the vitals look like. They don't have that much time. And so what we're trying to do, for example, is help accelerate that process. So with natural language, machine learning, we're trying to help physicians identify where they should focus their attention and have that conversation with the patient. So lab results came in from last week. It looks like this is higher. You're more hypoglycemic or diabetic, right? Here's what you need to do. Based on lab results, based on imaging data, based on this, here are the 3 or 4 areas that as a physician, we would like you to focus on, have those conversations with patients. Now, if we, from a commercialization perspective, go instead and say, hey, Dr. Khan, we have the best things to slice bread, he's going to sit there and tell me, I don't believe you. How do I know that your technology is better than what I have, or I can do better, right? He's a physician who has many years of experience, right? And he's going to sit there from a commercialization perspective, sit there and want to understand is how valid is my solution from a quality perspective, from a HIPAA perspective, from a return on his time perspective. And so from a commercialization perspective, we always work with physicians or nurses or MPs, whatever, from a health system perspective to address the needs, the metrics, and the quality of the results. And then the most important thing that we talk to the physician is because they're so constrained from time, we from a commercialization perspective need to ensure that our product fit in the workflow of a physician. What does that mean? it means that if a physician is using EMR system A, I don't ask them to go to this other system and do something else and come back. What I need to do is ensure that my product, my solutions are embedded or integrated into an existing other workflow. So part of our partnership is working with folks like Dr. Khan and physicians in general, but also to work with EMR vendors, such that our products are enabled in the EMR vendor, such that a physician can go and leverage it in the same process that we see. So in some ways, commercialization is multiple components of it. Part of it is understanding the technology, understanding the capability, right? But also understanding the bigger part of the story, which is how do I get from a nice technology idea? How do I build my machine learning? How do I build my model? How do I deal with biases and all that interesting stuff? But at the same time, how can I get physician feedback? How do I enable? How do I improve on it? And how do I make sure it's part of a larger process that people will set up? That helps.
So at the big annual radiology meeting, it's called RSNA, which takes place the week after Thanksgiving every year in Chicago at the Park Place. About 50,000 people somewhere in there attend. Last year we had about 34 vendors in the machine learning area. That doesn't include, these are mostly some startups, but right, also some of the big equipment manufacturers are working in this area. This coming year we'll have over 70 in that area. It's growing quite rapidly, and in fact a lot of the program content of the meeting has to do with AI. We on the physician side get approached pretty regularly. We've had a number, I've had probably at least a dozen, between a number of us in the department, right, 2 dozen contacts from various manufacturers of systems wanting to do some kind of partnership with us. The one thing that we have as a medical practice that is valuable to a commercial developer is we have, for example, data. We have images. If you go and start up a company, you have a brilliant team of engineers and you can get the technologies, but the challenge is linking that and connecting that with images. Just Penn Medicine, to give you an idea, we do that through our health system, we do about 1.2 million exams per year. So there's a lot of volume to be read. Now, along with that, as you're saying, I mean, the opportunity is tremendous for what it can do to help physicians along the way. A lot of people are familiar with the Google ImageNet project, right? And distinguished cats from dogs, and people, saw that kind of research and said, oh, okay, so we can find pneumonias now on chest X-rays. And to some extent, they can, and it would be tremendously helpful to have tools that, for example, look at chest CTs to find small lung nodules that potentially can turn into cancers. One of the areas in which these sorts of systems can be highly productive, and some are used, in fact, already, is to detect stroke, hemorrhagic stroke, for example. And because in general, the faster you can get a patient to treatment, the better chance they have of recovery. So all of these things, imagine having as your assistant, all of us, as soon as the studies get done, we try to read them as quickly as we can. But imagine having an assistant who's right there, who reads them the instant they come off the scanner within a matter of seconds and doesn't get tired at the end of the day, and still going at 2 a.m. And so there's tremendous potential of these tools to help the practice of medicine, both the detection of abnormalities and going forward. And there's a lot of interest in the space.
From your experience working with some of these commercialized products, there's obviously great potential. Where do things sort of fall apart sometimes when you're trying to implement in the
Well, I think as indicating, one of the things that one has to be very attentive to is how one tests and proves that these systems are valid. Just to give you just a very simple example, I was shown a system that finds lung nodules at a scientific meeting recently, and I was looking at it, and the settings on the device, it found the nodule. It said, here's the nodule on the chest CT. And I said, boy, that nodule looks really dense. Could you show me the soft tissue window instead of this lung window image that you have? And they showed it, and the nodule was calcified. Calcified nodules are basically little things that mean you had a little infection of a sort that your body took care of, and it's basically done. You don't see it so much on the East Coast, for example. In the Mississippi, Ohio River Valley, for example, everybody has histoplasmosis, fungus, and so calcified lung nodules are just something that you don't even think about when you look at these things, and you exclude from your consideration. And so, having a system that finds these nodules and points out calcified nodules to me is helpful. And in fact, one of the challenges is that with mammography systems, for example, that in order to achieve the sensitivity, in other words, in order for them to detect abnormalities at a high enough rate, they have to signal false positives as well. And typically, these systems work at 95% sensitivity or better. And they have something on the order of 1.6 false positives per study, per patient. So that means you're going to get little marks that show up on the images. Spend your time looking at it and then effectively remove and say, no, that's not really a lesion, and use your judgment and overrule the system. And these things, that's been the challenge with a commercial system like that, is that it doesn't speed up the process of the learning curve. Most people who work in mammography field, for example, feel that use of the particular AI systems in that setting.
We're trying to develop these technologies and there's so many different use cases or like how do you account for all of that with model?
Very good question. So let me start with something else. I've seen a lot of times there's a bit of a disconnect between the marketing of a technology and the development of technology. In many cases, sometimes I'll see like technology marketed as containing AI, and it's nothing like that. To me, it doesn't actually contain any recent AI technologies. It's something like maybe a very set of hard-coded if-then-else rules that could have developed as an expert system in the 80s. And it's just that it's just this very large system put into place. Now, the marketing people got involved. They're saying this is the latest in AI. Whereas there's a lot of other technologies which include things like automated image diagnosis, which actually do incorporate some really nice AI technologies, but it's always blended with a substantial amount of software engineering. So to me, one of the biggest ways in which these can be successfully developed is to have a diverse set of people involved in the project who are actually looking at, so you need people who maybe have a background in more on the machine learning side of development. You may also need people who are physicians who can look at this with a critical eye and say, yes, this is actually useful. I need this explanation which your algorithm can provide. It's providing because we didn't choose an algorithm which can provide these kind of explanations. So one of the biggest things I've seen in working with physicians is they need a way of drilling down into the justification for why something was predicted in a particular way. So it's not just enough to say that these are the lesions on the image. What you want to do is actually highlight why these are the case. It may involve looking at related records, might involve different views of that same particular lesion in order to give the physician information that he or she needs in order to really understand, is this a correct diagnosis or is this not by the system? In many of the algorithms which are currently being applied, especially when deep learning is a very popular terminology that's been thrown around a lot. To me, deep learning is not an algorithm, it's more a collection of problems which require multiple different levels of representation and understanding in order to solve. And so the deep learning, like deep neural nets, just happen to be one type of technique to solve these kind of problems. But most of those algorithms don't really understand what exactly they're making predictions based upon. They're looking at a large set of training data from which they've extracted patterns that recur and are useful for making these predictions, but there's a lot of studies now that show that if you like perturb random pixels in the image without changing, say, the high level qualitative image, you can fool the machine learning system. To me, that says that what's happening is these algorithms really aren't understanding to the depth that we need in order to make highly dependable automated decisions. So there's a lot of technology development going on behind the scenes to try to rectify this problem. We're not quite there yet. It's still going to involve many more years of development, but at the same time, many of these technologies can be commercially applied very successfully. But in order to figure out the niche applications where they can really shine, we need to look at experts and talk with experts in different areas.
Maybe a final question before we open up to the audience. We talked a little bit about the challenges and the overnights. What are the things you're sort of excited about in the next 2, 5, 10 years with development of healthcare applications?
Okay. So one thing I'm really excited about is the increasing, I'm going to go back to the partnerships thing. I think, so machine learning techniques and AI techniques, those are very fancy tools. But without a job to accomplish, the tools aren't all that exciting. So one of the most exciting aspects of what's happening nowadays is the partnerships that people are bridging between AI, medicine, law. All these different applications are coming in with new data sets that in machine learning and AI didn't have access to before. And so that's where you're seeing a lot of innovation. And that's what makes headline news. That's what makes publications in science, nature that gets people's attention. It's what new things are enabled by this technology. And many of these algorithms in deep learning, they've actually been around since the 1960s. They're not new. We're allowed to solve problems using them because of advances in hardware and software, things like automatic differentiation and other techniques which have been developed. There are some new algorithms being developed, yes, but a lot of the core functionality is really the marriage between technology and an application that's now getting people's attention. In terms, I'll talk a little bit about the technology development, the things that I'm excited about. I am excited about the ability to really understand the decisions that these algorithms are making. There's been a lot of emphasis recently in explainable AI or interpretable machine learning models where you can have an expert, this could be any application, healthcare, law, anything. You have an expert look at the decision made by the model and try to really drill down and understand why they made that particular decision. And in many cases, what we're finding is the support, in other words, the different representations that are learned along the way, aren't really grounded in physical features that the clinician might pay attention to. And so now by adding in the explanations, what they're starting to do is take those intermediate essentially representations of decisions that are made along the way and really ground them in things which make sense to us. And so in turn, what's happening is the systems are starting to focus more on features that can't be fooled by, say, random perturbations of pixels in an image. They're starting to look at much more higher level features and make sure it's a cohesive decision across all levels, all the way from pixel level of an image all the way up to the high level decision and explanation along the path. I'm also excited by to reuse information. So this is the particular area of that I work in, transfer lifelong learning, where instead of gathering up a massive data set over years or dozens of hospitals, what you can do instead is continually build upon the knowledge which has been learned across multiple smaller data sets. This, to me, will enable better advances in personalized medicine, where you can handle the small differences between individuals and different geographic regions, like you mentioned, like osmosis and such, which occurs within certain geographic regions. These kind of things, you could allow the system to adapt to say, okay, well, now we're in Ohio. I need to be able to handle these sort of
situations. You might be able to detect that a patient has these and predict where they might have traveled. I'm not sure. But allowing much more personalized medical decision making, I think, is going to be pushing into the trends in precision medicine, personalized medicine, traceability. All of these, to me, are worthless unless they equate to better patient outcomes in the end. That's what really matters. Giving physicians time, again, is useful, but again, it all goes back to the patient. It goes back to benefits to the physician as well. Obviously, reducing overwork, allowing them to look at higher patient loads, things like this, allowing them to handle more complex cases with higher confidence, allowing justification of particular decisions. So insurance companies, for example, won't deny cases, which should otherwise be covered. All of these equate to better patient outcomes. That's what kind of really matters in healthcare, and that's the goal that I see.
I'm glad you mentioned partnerships. So my title is Director of Partnerships. So your point, partnerships has become a big thing. It's always been a big thing. But I think now healthcare is critical in understanding that each entity in itself doesn't have all the answers. And you need to collaborate together and across in a positive way to get anywhere. So it used to be, I'll give you an example. It used to be that hospital systems, health systems, and payers, insurance companies, don't get along. Not for various reasons, right? And so what happens is there's siloed data inside of plans. So if you're a patient, you go to Penn Medicine, and for whatever reason, Penn Medicine has all the information about you, your vitals, your history, etc. Whatever reason, you decide to go out of network. Penn Medicine completely loses focus, and loses all attention, has no information about what you did. Who has that information? The payers. Your insurance company. Insurance company is not going to tell, per se, health system what they know. And the health system is not going to want to tell the payers what they know. Interesting problem, right? So recently, you probably noticed, now there's a relationship between Penn Medicine and the Blue Cross Blue Shield. Why I think that's the case? Share information. You want to do what's called population health, right? I'll be overly simplistic with this conversation. Why is that important? Penn Medicine wants to treat patients better, but they need to have access to all the information. Insurance companies want to treat patients better, but also reduce costs, so they need to have access to information. So they say, I know something, you know something, we can share, we can enable care coordination, care management, to help identify what we should do with patients. How does that inform? With the AI, the things called segmentation, cohort analysis, right? Basically bucketizing your patients into high risk, medium risk, low risk. If I can identify which part of my patient is high risk, I can do something about them, be proactive instead of reactive in addressing their needs. That's where a lot of the data mining and machine learning tools are coming very helpful, both from a health side as well as insurance company side. Right? That's something that has changed the last, I'd say, that's a major change. And that's why you're seeing, frankly, you're seeing health systems buy up insurance companies. And insurance companies buy up health systems. It's for that reason. That's a major shift in the world, right? The other thing to think about is kind of giving for cyber perspective. Again, my background is text mining, unstructured data text. How do we see that read reports? Imagine you're a pathologist. You have a gene sequence that came out, and you're trying to, based on the gene sequences, you're trying to figure out what is the diagnosis of this person. What treatment should I give? What should I advise? The pathologist's job is to sit there for 20 hours, 30 hours, read through literature, paper after paper after paper, figure out, connect the dots, that maybe that this enzyme with this component, with this medication, with this person, with this genetic sequence, this is the treatment I should give. Very manual intensive. So what's happening now is that the use of concepts, use of understanding what certain wording means is helpful. So there's standards now that are coming out which will do MLS or Snowman, which helps annotate words in literature. Why? Define concept, such that a concept could be related to another concept, so therefore you can get some value. But gene sequencing, right, which has become a big thing in the last 5-10 years, right? It's like Illumina, right? Now you're enabling and accelerating the process. And so the ideas of text mining and data mining has become extremely helpful in that area to accelerate answers, accelerate results, right? And so those are examples of where data mining, machine learning, combination of technology, combination of physicians, combination of other partners helps enable a solution to get somewhere, right? You can think about it. What's the problem you're trying to solve? How am I going to solve it? How am I going to prove it out? How can I commercialize it? If you don't have all those things, it's hard to get in. Right? Hopefully that's all.
So just to your question of kind of what's, I have to agree, the exciting part from the science standpoint, the best stuff always happens in the first years. It's right when you bring people with different backgrounds together, different ideas, when you put the computer scientists, the physicians, the engineers, the interface designers, you get the artists, you put people together from different backgrounds, and that's when really exciting stuff happens. I agree very much. I think in the next 2 years, probably the explainable AI, interpretable AI is going to be one of the things that's really key. I don't know if many of you have seen some of the pictures, if you've seen them. They're called heat maps or saliency maps, for example, in medical imaging. So you see a picture of a chest X-ray, and the idea is the computer then, in addition to showing the X-ray, it shows you kind of a color heat map. In other words, red areas looks like thunderstorms moving across the thing. But then it shows you in color the areas that the computer is sort of focusing on as areas. Now, why is that important? I'll give you a really simple example. When we take a chest X-ray of you as an outpatient, it's typically done with what we call PA, with your chest up against the film, if you will, the detector. For patients who are inpatients in the hospital, that's typically done, they're on their back. So you put the detector behind their back and you take the image that way. So there's a little label that gets placed. Usually we have an R on the right side or we put an L. The thing is done AP. So somebody developed a system that was brilliant at finding people who are at higher risk for pneumonia and aspiration. So when they looked at the saliency map, this heat map, the thing that showed up as the most significant factor in making the determination was the letter L off in the corner of the film, because the thing had decided that the best way to tell if somebody was sick was if they were an inpatient, which was clued by the letter L. All right? So it goes to a lot, so this is where, for all of us, we really need to focus on, having a team of people who bring diverse backgrounds to it. You got to have, the best thing to have is you need to have the zealots. You need to have people who truly believe that AI is going to work. And those up here, we're believers, but you also have to have a skeptic on the team as well. You have to have someone who's willing to check and double check, because these are people's lives that we're affecting with the technology. And we really want to use AI to improve the way we deliver care to our patients. That's, at the end of the day, that's the bottom line for things that we do.
Thank you so much for your insight. We'll now open it up to the audience. Anyone have questions? Okay, you go first.
So sort of piggybacking on that last one, I don't think the FDA should regulate AI.
We repeat the question, how do we think the FDA should regulate AI in healthcare?
That could be an hour conversation in and of itself. As you know, the FDA has 3 classes of regulation, and I'm not going to get to the terminology, but basically class 1 devices are band-aids, kind of low-risk systems. Class 2 are systems that are kind of intermediate risk. Class 3 are systems, things like stents and various devices. FDA has indicated that they're willing to look at many of the things that are developed in the machine learning AI sphere for healthcare as class 2 devices, in the sense that they're always going to be overseen by individuals. In other words, although the thing points to the chest CT and says, here's a lung nodule, it's still on me to determine if that's a nodule or not, and I'm still the one kind of held responsible. It's not as stringent a test as it would be, for example, for a system that is going to be, let's say, adjusting people's doses of pressors in the intensive care unit automatically based on their blood, on a real-time closed loop system. Probably best to ask our corporate representative, how we believe the FDA should regulate the.
Absolutely, I think absolutely, and one of our businesses, our imaging business, is FDA. We're doing some work with Medtronic now, with diabetes, that's FDA. So, it's absolutely right. One of the things that a lot of our tools, our decision support, they're meant to, in collaboration with a physician or a nurse or a nurse practitioner, to help identify treatments or conditions. It's not meant to diagnose or other kinds of. So we have to be very careful from a legal perspective. From law, right? We have to also be very careful about what we say, what we say. That's kind of how we work. Again, the FDA said transit community be level 1. Again, depends on the situation.
We'll go back corner.
Can you talk about some more specific ways that academic medicine can contribute to the development of these types of programs and providing?
Yep, so the question was, how can academic medicine get more involved in developing some of these applications?
Well, finding partnerships with developers, so working with people in computer science here with the engineering school. We actually also talk to people at Drexel, for example, across the street, because they have a very active engineering program. We have actually within the radiology department here, there are about 40 research faculty and probably about a dozen of them are doing work in the machine learning space. So it's kind of there are lots of problems to work on. And it's kind of getting a combination of data to work on, the equipment in order to do the crunching, which we got an equipment grant, for example, for the department, and then having some people to do the work. I just got another meeting and talking with a group of folks about when people approach these problems. For a lot of these machine learning tasks, about 70% of the effort is data wrangling. It's actually getting the data into a form that you can start doing the work on it and then cleaning it up. So in other words, I mentioned, the large volume of reports that we generate, for example, but just having report data makes for very weak labels to do machine learning. So you really have to be very attentive to doing it. And then you have to think of some of the other issues we talked about. We talked about bias. You have to make sure that what you've built for training these models is indeed a representative sample, that you haven't, you trained it on 50 cases and it worked great, except what you taught it was how to memorize those, basically it's learned from rote rather than learning patterns. So there's a lot of detail that goes into it, but certainly a lot of the large academic centers either have programs. The Partners Healthcare System, Brigham and Mass General have a group that does that. Stanford has a large group that does this, and a lot of other major universities have data science groups.
Yeah, so I think that in order to really impact partnerships within research centers, we also need partnerships with the commercial side, right? And we also have to have AI in its relation to what's known battery. Like how do you like data assets right into the commercial space? That's now bringing over a lot of ethical and commercial lines. So where do you think that commercial academic partnership needs to move, especially in the data space?
Okay, so to repeat the question, how do you move commercialization of research and academic space into the market without infringing on some of the HIPAA violations or data privacy and data ownership violations?
Let me think it's that. So there's two parts to think about, right? There are certain projects or initiatives that start within an academic center that you would want to be commercial. There's the reverse, which is a commercial entity that comes and says, we have a product that we would like to leverage or partner with you on. Right? So in the case of Memorial Sloan Kettering, for example, it was a latter. It was IBM going in and saying, we have a capability in the area of oncology that we would like to collaborate with you because we, as a commercial entity, do not have data, we do not have rights to the use of that data. Right? So in that situation, we actually worked with Sloan and various other oncology centers to try to enable that model. Now we talk about biases, right? Memorial Sloan Kettering has a certain type of a clientele population. So you can't sit there and say, I'm going to build a solution only on the demographics of Manhattan. Because that demographic is going to be different than Philadelphia. Right? So what you naturally have to do is you have to go to, Indiana, you're sitting in Texas, you have to go to Penn. You have to go to Memorial Sloan Manhattan, go to UNC Chapel Hill, right? And create enough of a large data capability to enable that conversation. Now, we hope in that process that you have enough of a different set of a population that you can break down as much of the biases as possible. There still may be people that we're feeding for various reasons, but at least you try to minimize that opportunity. Commercial entities don't have access to data for a specific reason that those are owned by the person and the health system. And so at times we would actually have to go to a health system and say, we would like to leverage your data for this project. The health system may say, they may be willing or not willing. If they're willing, they can give de-identified data, right? And even in a lot of situations now, we're sitting there arguing about, does the health system have the right to actually give the data to a commercial entity on behalf of a patient, or do they need to go to every single patient and ask permission, right? So that's a different conversation for a different day. But even the legal terms of what the health system is allowed to have, even its own four walls, is even available to external. And that's what really frankly where commercial relationships with health systems, with academic medical centers is critical, right? Because we don't have all that information. And for a lot of ways, right, from a Penn perspective, you have a lot of the components in the four walls, right? You have it within Penn medicine, within engineering. You have all the different divisions within the organization. And there's obviously some conversations to have, at least within the four walls of UPenn, right? IBM and Google and everybody else, we have to have collaboration. And we have to figure out where it makes sense to have collaboration with. We can't boil the ocean with 20 million projects. We can't work with everybody. Where are our priorities? What do we want to work with? Where does it make sense? Where are the right personalities, the right opportunities? What conditions do we want to focus on? How to pursue that.
So you mentioned a lot about the abundance of data in healthcare. Given the multiple standards like PACS.com, Fire, really all over the place of data in healthcare, can you comment on the future of data sharing, data standardization, and this idea of open data in healthcare?
The question was, could you comment a little bit on the future of data sharing, especially with the standardization?
Sure. Yeah, so I don't know how many of the folks here in the room, for example, know some of this, but DICOM is an international standard for sharing medical image data. It's basically baked into every CT scanner, X-ray device, MRI, ultrasound, and viewing system. And actually, within the DICOM standards group, they're actually working to create standards for exchange of information from machine learning systems. I think the Standards Act side of it is actually pretty well covered to some extent. I mean, the fact that we can exchange medical images around the globe, and we've been doing it for since the 1980s, is kind of a landmark. So I'm not particularly worried about that. There's also work that's going on through various radiology organizations and also through standards committees such as DICOM and HL7. And HL7, by the way, is the standard for pushing information from healthcare systems to each other, like from the electronic health record to a radiology system to that covers a lot of this. So, for example, even for let's take mammography again as an example. There's already a standard in place for putting those little marks on the images, for example, that would say, look here. So that's actually been part of the DICOM standard for about 15 years now.
So I want to mention two things that are still in the research stage, but may be relevant to some of the questions that we've had here. The first is you could certainly have a bunch of data, images, and then each time you've got a model, you retrain from scratch. That's very, very expensive. You can't see access to all the data. There may also be ways to start abstracting aspects of knowledge from the images you've seen before and then moving directly on that. So that's like areas of transfer, which allows us, we don't actually need access to the data, but we need to have some kind of knowledge extracted from it. Another area of machine learning research, which is, I think, quite relevant to the discussion here, is privacy preserving machine learning. So this is, even if you have a bunch of different organizations, all of which have their own data, and you somehow want to aggregate information together at the population level without giving up access to individual records, you can use these kind of techniques. So a simple example of that is, imagine I wanted to figure out who in this room, or what percentage of people in this room achieved learning. I probably don't want to have you raise your hand for that. Chances are people are just not going to be comfortable with that. So instead, what I can do is give everyone a coin of some kind, maybe a weighted coin, and you flip it. If it comes up heads, then you answer yes, and otherwise you answer true. Okay, and so in other words, there's guaranteed, like when it has a coin, I'd expect about 50% of people to raise your hand, right? No one should know but the point is there's some subtle variation of that, because I know at this point, I can measure the statistics about how many people have actually achieved without anyone revealing whether or not they really have. So there are techniques like this that are in the process of being very quick thing on standards. Standards have existed for a long time. It doesn't necessarily mean the parties want to use them. Just not one. It's for some part of the ecosystem, right? Or certain people have access to the data, they control the data. They don't want to share it for various reasons. And so the challenge becomes is how do you convince them to share? Or two, how does the government define rules that they have to share? Right? So there are definitely parts of the vendor space that are not willing to give access to others. Right? So specific EMR vendors own a lot of data, and they are not willing to share that data. Right? And so not allowing others to leverage that data puts a limitation on the larger ecosystem to improve and innovate and grow, right? What their thought process is they want to be the central hub for all patient-related interaction. And if that model continues, then they become monopolies, right? Essentially, Epic or Cerner or whatever your favorite 2 or 3 are, they become monopolies that own the world. Right? So they become the Googles of the next 5 years. And so there's a lot of conversation with public policy, and I can talk about it next time. A lot of conversation about public policy and government regulation about how do you break down those silos that allow people to leverage it.
The only issue I would take with that, and I recognize that one has to be careful of sort of monopoly power in that regard, but I would argue that Epic, which is our vendor here for our electronic health record, does not own the data that Penn Medicine owns the data and some of our patients own in the same way that you put things on Google Cloud or Amazon Web Services in a private cloud. They don't own your data, you own your data, you're just renting the locker in the storage space. There are techniques, and I know that the technique that was mentioned for surveying is one that's been used for doing very sensitive subjects like finding it, looking at asking risk factors and things like HIV and so forth. And it's proven to work very well. But there are actually even technical techniques that are being developed. In other words, if we have between Penn and Stanford and Harvard and pick another institution, we all decide to collaborate rather than trying to push all of our data into one big archive with all the attendant risks of HIPAA violations and all that. The other thought is to push the model around, train the model on our data, then I send the model to my neighbor, they train it on theirs, send it around, and we play round robin with it a couple times. And that preserves the privacy of the data. I will tell you, going forward, there are some really interesting and exciting questions to ask with these things. Because, for example, CTs, MRs of the head, you can reconstruct the 3D face, right? And you can then match that against, say, a database of driver's license photographs. So there are particular issues that relate to the ethics and privacy and other things that relate to the healthcare data that come with this old brave new frontier.
Thank you all so much for coming and agreeing to be on our panel today. We really appreciate it.